What if the most destructive things in the universe are also its greatest creators? We're going to the edge of reality to meet cosmic titans that eat light and bend time. These aren't just empty spots in space, they hold the universe's biggest secrets, and for the first time we're starting to figure them out. We're heading into the heart of darkness to understand the most powerful and baffling objects out there. For a long time we thought we had them figured out. A dead star collapses, gets so dense that nothing can escape, not even light. Seemed simple enough. But what if that was just chapter 1 of a much weirder story? New discoveries are showing us a completely new picture. We found monsters in the dawn of time, black holes so huge so early in the universe that they shouldn't exist. We found the hearts of galaxies that don't play by our rules. The universe is hiding things that can swallow stars whole. And they're shaking up everything we thought we knew about physics. Before we get to the really weird stuff, you need to understand just how big these things are. Forget the picture of a lonely monster drifting in space. The biggest black holes are the anchors of entire galaxies. At the center of almost every big galaxy, including our own Milky Way, there's a supermassive black hole, a beast with the mass of millions or even billions of suns. We used to think of them as quiet landlords, just sitting in the middle of a city of stars. Now we know the relationship is much more active and violent. The size of a supermassive black hole is directly tied to the size of its galaxy. They aren't just living there, they're shaping the whole thing. As gas and stars get pulled in, the material heats up into a spinning inferno called an accretion disk, which blasts out incredible energy. That energy can shoot out into the galaxy in powerful jets, controlling how many new stars can be born. The black hole acts like a galactic thermostat, deciding the fate of trillions of stars over billions of years. But this brings up a huge question: which came first, the galaxy or the black hole? They seem to grow up together, but finding gigantic black holes in the very early universe, when galaxies were just babies, messes with that idea. How does a tiny young galaxy create a monster that already weighs a billion suns? It's one of the biggest puzzles in astronomy today. To understand these giants, we have to get closer to the most famous border in the cosmos, the event horizon. People call it the point of no return, but that doesn't really capture how strange it is. Picture space-time itself as a waterfall, pouring into the black hole faster than the speed of light. If you cross that edge, you're getting carried away no matter what you do. If you were watching from a safe distance, you'd see something that would break your brain. As the spaceship got closer to the event horizon, its clock would seem to tick slower and slower. Its light would get stretched out and redder, a process called gravitational redshift. The ship would look like it was frozen in place right at the edge, fading away over what seems like forever. Like a ghost, haunting the border of reality. But for the poor astronaut inside, it's a much faster and more horrifying trip. There's no wall or signpost. You just float across the line, not even realizing your fate is sealed. The journey ends with a weirdly brutal process: spaghettification. The black hole's gravity would pull on your feet so much more strongly than your head that you'd be stretched longer and thinner into a stream of atoms, a cosmic noodle flowing into the void. That's what happens to anything that gets too close. If you could somehow survive getting past the event horizon, what's at the very center of a black hole? This is where our understanding just stops. At the heart is the singularity. It's not really a place, but a point in time where all the mass of the black hole is crushed into a space with zero volume and infinite density. At this single point, the laws of physics as we know them, including Einstein's general relativity, completely fall apart. The math doesn't work. Our ideas of space and time lose all meaning. What even is infinite density? We have no idea. It's the ultimate dead end, a place where the universe as we understand it simply ends. So what do physicists think is going on? The theories get pretty wild. Some think a singularity could be a wormhole to another universe. Others believe the information of everything that falls in isn't actually destroyed but is saved on the event horizon like a cosmic hologram. Another idea is that quantum mechanics, the physics of the very small, must step in to stop the infinite collapse, creating some new exotic state of matter we can't even imagine yet. For now, the singularity is a wall, reminding us that our knowledge has limits. For decades, black holes were simple, a one-way trip. But then the legendary physicist Stephen Hawking came along and flipped that idea on its head. He realized that black holes shouldn't be completely black. They should have a very faint glow, something we now call Hawking radiation. According to quantum mechanics, empty space is actually a fizzing soup of virtual particles that pop into existence in pairs, one matter, one antimatter, and then immediately cancel each other out. But if this happens right on the edge of an event horizon, one particle could fall in while the other escapes. To an outsider, it would look like the black hole just spit out a particle. The implication is huge. By spitting out these particles, the black hole is losing energy, which means it's losing mass. Over mind-bogglingly long timescales, trillions and trillions of years, a black hole will slowly evaporate until it vanishes in a final burst of gamma rays. They aren't eternal after all, but this fix creates a brand new problem that physicists are still losing sleep over: the information paradox. If a black hole disappears, what happens to the information about all the stuff that fell into it? A fundamental rule of physics is that information can't be destroyed. So does it just vanish from our universe, breaking the laws of reality? Or is it somehow encoded in that escaping radiation? The answer could rewrite everything we know about gravity and quantum mechanics. The puzzles get even bigger when we look at the universe's true monsters, the ultramassive black holes. These are the top 1% cosmic giants that make the supermassive ones look tiny. Take Ton 618, a quasar whose light has traveled for over 10 billion years to reach us. At its center is a black hole weighing somewhere between 40 and 66 billion times the mass of our Sun. Its event horizon is so huge that our entire solar system could fit inside it many times over, and Ton 618 might not even be the biggest. In a galaxy cluster about 5.8 billion light-years away, there's Phoenix A, a black hole with an estimated mass of 100 billion suns. It's so big it's pushing up against the theoretical limit for how large a black hole can get before the disk of gas feeding it just collapses and forms stars instead. These monsters give us the ultimate chicken and egg problem. The James Webb Space Telescope is finding these huge black holes just a few 100 million years after the Big Bang, a time when the universe should have been in its infancy. There just wasn't enough time for them to grow so big by slowly eating stars and gas. How did they get so big so fast? Theories that sound like science fiction are starting to pop up. Maybe the first seeds weren't dying stars, but something else entirely. One leading idea is called direct collapse, where massive clouds of primordial gas in the early universe collapsed straight into a huge black hole seed, skipping the star phase completely. Another even stranger idea involves cosmic strings, hypothetical cracks in the fabric of space-time itself left over from the Big Bang. These strings could have acted like gravitational superhighways, pulling matter together rapidly enough to form these impossible giants. Whatever the truth is, these early monsters are telling us we're missing a key part of the universe's story. From building galaxies to the brain-breaking physics of the singularity, black holes make us question what reality even is. They aren't just holes, they're cosmic laboratories where the laws of nature are stretched to their breaking point. We used to see emptiness, but now we see the engines that drive the universe. We used to see eternal prisons, but now we see objects that slowly die, possibly holding the key to the ultimate fate of information. The more we find, the weirder the questions get. And studying them isn't just about black holes. It's about understanding where galaxies came from, what space-time is made of, and where we fit into all of it. With every new image from telescopes like James Webb, we get another piece of the puzzle, bringing us closer to the heart of it all. The answers are out there, waiting in the dark. If this journey into the cosmos blew your mind, make sure to subscribe and hit that notification bell for more deep dives into the universe's biggest mysteries. And check out our next video on the wild possibility of alien megastructures. Thanks for watching.